So I can start?
Yeah, sure, go ahead.
Okay. So everyone can hear me well, I hope, and can see my presentation. So, same pattern, Redux on steroids. Well, no, I think it's much more from my point of view. Same pattern was created by Jean-Jacques Debray several years ago, and it defines some semantics taken from us and allows to write the code that is precise, robust, and scalable. SAM stands for State Action Model. So how SAM is different from Redux? Well, shortly, asynchronous and automatic actions out of the box. Semantics of SAM are very natural and straightforward. No function generators, no action mappings, no action subscriptions. You just focus on the logic that is important. Sounds cool. How does it work? Well, let me show you. Let's take a look. I think I will need to switch the presentation to a different window. So let me know if you don't see, but I think you see the editor, I hope. So this is just a scheme, and this is how the loop happens in the SAM. We have action. Action is a bit different from Redux in the way that it's a function. It's not an object. And once action is done, it can be invoked by some input event, for example, from the user. And then it creates a proposal. Action is a pure function related to the model, and creates proposal as an object. Then this proposal is passed to the list of acceptors. Those are functions that take model and proposal and modify model with using the data from proposal. And after all acceptors do their thing, it goes to the list of reactors. Reactors now is just, let's say, some way to reflect on what happened after a list of acceptors happened, and to add some additional changes to the model. And all this happens in the synchronized way here. Then the model is passed to the viewModel function, and it creates a state. And this is like there is no modification of models as well, pure. And then we have the state is passed to the nep function. This is called, stands for next action predicate, and it's called predicate because it returns a boolean, and it decides the role of this boolean is to decide if you want to render in this cycle or not. And as well, nep is responsible for invoking some next action. So it actually can invoke some action, a next action, and run the loop again. Yeah. And once, let's say, state nep returns false. So false means no next action. Then it can render the state. Though it's actually allowed as well return false if you have some asynchronous next action as well. So just short piece of code maybe here. It's just to illustrate it a bit, maybe even more. So we have this singleton. Yeah, this is intent. It's called, this is how the wired action is called. Wired actions means the action that is wired with all this loop. Basically a function that runs the events through this loop. And yeah, you have an action called to get the proposal. You run it through the set of acceptors from the reactors, and get your state using viewModel, and then you check if the nep is false, and you render. So that's SAM in a nutshell. Let me change the screen back to the presentation. So probably you can find some similarities and with Redux, and now I can think something like, okay, action generator is something like action synchronous in SAM. Epic sagas, it's something like next action predicate, asynchronous action in SAM. Action is basically proposal, reducer is accept reactor, and state is model and state representation, or something that is state representation is basically what we get from the vmodel function. So sometimes it's called like state representation. Well, is it right? Well, not really. I think there are many details that are quite different, and we will see that more in the examples that I'm going to show next. So in our examples, we're going to use SAMLib. It's after implementation of the pattern, basically. Yeah, let's see the wiring. By wiring, I mean how you wire all these actions, acceptors, and everything. Let me find the link. Yeah, so here I just have a simple wiring already defined. So we have this set render hooks that we get from our implementation. I put intents in some different model, and I will show it in a minute. And yeah, we need this kind of render function that we pass to set render so that it will call once the step is finished. And we can call already intents here just to start the loop and add some data. So let me go to intents. So intents, yeah, again, I think quite simple. You have several hooks from our library, like we had initial state, we had our component, which is basically some object that collects all these actions acceptors, and here you will put the actions acceptors as a list. I think quite simple, straightforward. Okay, so yeah, this like the examples that we're gonna take today is just very simple to-do app, like extremely simple. You have just for now, it's like basic input. You can put some new to-do here. It will be created and will be at the end of the list. And what I want to show is examples of the asynchronous actions, how they're happening. Let's review how they're happening in epics and sagas. We will need basically two asynchronous actions, one to get all to-dos and another one to add to-do to our backend. This is something like how it can look in the sagas. I think everyone is familiar with that. So just to review, and also I wanted to show that we need this to make this refresh of to-dos. We fork it like another saga here once we add the to-do, which is maybe not the best way to see how SAM will handle this. This example of observable, also I think quite straightforward. Yeah, the only difference here is that so maybe it's like here I define it by using another action, and then I subscribe for this section to actually invoke the epic, but I think it's not necessary to do this way. It could be similar to sagas as well. So let's see the SAM finally. That's how actions are looking SAM. As I told, they are just creating proposals. This is our proposal, a simple object with some field. This is another proposal that we have from refresh to do actions. And we basically invoke to the effects, we get the data, and that's all. No function generators. But I think if you want to use RxJS, like I think you can use it as well in actions. So let's take a look at acceptors, something that is similar to reducers maybe. So you get proposals, and as proposal can have many different fields. You need to check like okay, it has to-dos, so I will update the model with to-dos. Okay, edit to-do is not undefined, so I will update the edit to-do. Why to check for undefined, not only for false, but because we can allow also the null here as well. And a reset here acceptor is just the one that is run all the time, and it's used to reset the control state. And control state, it's something that helps us to invoke next actions in SAM. I will show you how we use this control state in our naps. So here we define a simple nap. I think it's very separated from compared to how we implement this refresh of to-dos functionality in sagas and epics. And basically just reflect that, okay, edit to-do was done, so I will invoke another action refresh to-dos, or let's say intent. And here I will also probably delay rendering, so it's not required. And you just add that snap. So that's all for the SAM. How we would do it in the SAM. Yeah, it's first automatic action refresh of to-dos that we had to handle. So you may say that, yeah, so far maybe not that different. I think you could probably make somehow the same construct in sagas and epics. Though I think already it can be seen that there is stronger separation of concerns, a bit easier to handle things just because Sam was thinking about asynchronous actions prior the pattern was designed, while Redux requires some middlewares. But yeah, I think things will get more interesting when we get more state. And let's go with some more examples that and see how they could be solved by sagas or how they can be solved by SAM. So let me again switch to the window with my editor. So just first, I just came up with some use cases. Of course, they are maybe not that realistic, but probably they can be translated to some realistic scenario. So for example, first example is what if we want to add some tags in our to-dos, and this to-do tag will actually make something that makes the to-do created as done already at the beginning. And let's say we already have from the previous implementation, we have some endpoints on the backend. So we have this kind of simple endpoint to mark to-do as done, and we have this endpoint to create a to-do. So what kind of options we have to support this scenario? One option, of course, is we can move all this complexity to the backend, and we can extend this like without changing anything on front end. It will, again, if you remember, we'll just call add to do, pass to do without any changes, and then on the backend we will reflect somehow on this. But I think it's probably not ideal solution because we need to change the endpoint, and it's not scalable because something changes again, we will need to change the endpoint again and continue with the solution. And probably we want to preserve the backend as it is and just use the API as it is to make it and preserve how simple it is to not add complexity to it. So we can break it down in two calls, like two requests. So we'll have something like that in our Saga, which is already as well, we basically move complexity to the front end and we concentrate it in one place. And again, I think it looks not ideal, of course, because add to do probably shouldn't know something about marking the to-dos as done based on some tags, as well as actually shouldn't as well maybe know that it requires refresh the to-dos after. So what we can do maybe next with sagas, we can also break down using several sagas. So you can see that we will add a new action. This action will be like we will get another saga that will subscribe to this section, and we'll do we'll extract all this functionality to another saga basically and mark our to-do as done. Well, this may work. Still, not sure. Not the ideal separation of concerns, I think, but this can work, and I think it's a bit better than previously. But another question could be, what if there is some validation in the reducer? And to-do edit doesn't know about any validation because it doesn't reflect on the state. It just gets the action, and action will always pass. But maybe reducer will actually do not accept this new to-do that we get. And then maybe something changed, and the state was already synchronized with the server, and it doesn't make sense anymore to actually mark this to-do as done. So we'll have to make this call that is likely to fail. Maybe it's also not ideal. Yeah, so we come with these problems. Probably the solution would be to reflect on state and add something that Sam already defines, something like control state in your state, in the Redux state, and be able to reflect that the validation was passed and this new to-do was actually added to the state, and this call still makes sense. Well, how you would do it in Sam? Well, this is something that will be defined as side effect action based on state, and something that will be implemented by a simple nap. And the way you want to do it with our, I think, previous solution, it will be that we will define a new function, nap, a new nap, and we will just add it, and we will just reflect on our state if there is edit to do, and edit to do includes done, we mark it as done. I think it's definitely looks like a responsibility for this function, and it looks quite well for me. So quite simpler, I think, compared, already not that complicated problem, but already creates some brain teasers for how to do it in sagas, while in Sam, I think it's quite straightforward. So sync issue. Let's say that we edit selected to do in our state. And the problem is that it could be that on the server, let's say to-dos already doesn't contain the selected to do anymore. And we need somehow to sync with that. We need to update our selected to do variable. So what we're gonna do in Redux, probably something like this, which is we can extend send to do's reducer, the one that we already had. Once we get to do's, we already have selected to do, let's say, with something. Let's assume that it's not now here. And we're going to try to find it, and we're going to put it as null is if not doesn't exist anymore in the new set of do's. Well, again, too much responsibility for set to do's reducer. It's not anymore setter, I would say. It's also concerns about selected to do, and this is some complaint that we introduce. Well, what we can do, other options in sagas. We actually can't delay it into sagas to imitate something like next action predicate from Sam, because sagas will be late to modify the state. So the state will be already modified, and the rendering will happen. And once the sagas will be invoked, if they will put some other action, like for example to clear the selected to do, it will be too late and will already render the incorrect state. Well, we could extend our get to do sagas and add new actions there to set selected to do to null, right? Again, some more responsibility. Yeah. And first option is about that we can, I think, reflect on the state in our sagas as well. But again, we extend something that worked before well, and probably it's not something that we want ideally. So same solution. Again, we have now these reactors that could be also used for that, and we also can use again the nap, because it's again something kind of like a side effect that we need to do. So we can add this simple reactor that will, as you remember, reactors they invoked after all acceptors pass. So we are sure that validation will pass, because validation will probably happen in acceptor. And then we just check and make our selected to do null if something is wrong. Maybe more better way is still nap. And here we can use something like this, and set selected to do something similar to what we already did. And we can add this control state, refresh to do's. It will be a bit more robust, because once refresh to do's happen, then we will actually make the action. We will not do it all the time, like recompute the selected to do, how would reactor would probably do. And it could be done synchronously. There is no restriction on that to be, so that we can skip rendering, not render anymore, and we actually do not allow anything else come to our model yet until we actually set this to null. Yeah, and actually there is another case here that we may also need to reselect the to-do, even if it's found, because maybe it was updated on the server and has, for example, new name. So it's, yeah. So one last example, it's about, let's say, what if we want to persist selection, then we need somehow to fetch it in our refresh of to-dos tool. And here I just want to show you the power of proposals compared to actions. In SAM, we would just add a new action, and this action would just extend and the proposal that was returned by get to do's, just add selected to do into it, and now we get the proposal that will be accepted by model and processed as it should. Yeah. Well, for Redux, probably we'll need to add another action, I guess, and do some rewiring in action reducers map. Okay, so that's all for examples. Let me switch back to presentation. Hopefully. Yeah, so besides, I hopefully hope that I was able to illustrate some advantages of SAM semantics that it introduces, and how it actually can simplify the logic for some a bit more complex cases. And besides that, as it's based on the mass, and you can get also some things like model checker, time travel, and safety conditions. And let me show you some docs about that. So safety conditions, it's something that you can add to your SAM model, or let's say to your component. And you can define some conditions when you think that something bad has happened, and something like the state is not in the right, the model is not in the right state. So what this will do, that it will basically roll back to the state that was safe before. And safe means that it was evaluating the safety conditions to false, I guess, here. So you can add several safety conditions, and then you can maintain your model and to avoid some unnecessary state in it. And time traveler. So we have these hooks for time traveler. We don't have, I think, because there is not the community is definitely less than by size than the ones that you have for Redux. So not sure if there exists something like browser extension to make time travel, but there is already hooks in the library. And basically, there is just basic simple APIs that you can use, and you can travel to different states and see, like debug the model as you need it. And the last one was model checker. And model checker is something that is basically kind of testing of the model with all possible states that it can has, and see if some bad condition, some bad safety condition was reached or not, or it's still live and like the state is correct. So you can basically run through the different, all the possible combination of the intents. Of course, you have to keep it reasonable because like the combinations probably could be like very huge amount of. So it's something that you need to restrict, but you can check how the model behaves and see how robust it is. Okay, so I think that was basically a quick review of the SAM for today. I would say still, yeah, probably it's not Redux on steroids because hopefully you saw some differences there. Yet I think it's a powerful framework on itself, and it brings a lot of advantages that Redux may be not good at. So let me know if you have any questions.